Welcome to this video on the binomial distribution part 2. After watching this video, you should be able to identify n, p, and x in a binomial distribution example, use StatCrunch to calculate the probability of an event in a binomial distribution, and construct a binomial probability distribution using StatCrunch. If you have not already done so, please watch my video entitled Binomial Distributions Part 1 before proceeding with this video. Binomial distribution, a note about checking the 4 requirements of the binomial. Every time you work a binomial distribution example, you should go through the 4 requirements of the binomial and make sure the problem you are working on meets all 4 requirements before proceeding with the problem. The lesson on meeting the requirements for the binomial was covered in detail in part 1 of this video. Therefore, for the examples in this video, we will assume we have already checked these 4 requirements and verified that each example is a binomial distribution. Defining variables of the binomial distribution. The letter n is used to represent the total number of trials. The letter p is used to represent the probability of success. A lowercase x is used to represent the number of successes in n trials. Calculating binomial probability. Example 1, flipping a coin. A person flips a coin 5 times and records the outcome. What is the probability that the coin will land on heads exactly 3 times? Remember, the first thing you should do is to check that all 4 requirements of the binomial are met. To learn more about this process, please watch part 1 of this video. Step 2 is to determine which event we're calling a success. Remember, success doesn't necessarily have to have a positive connotation in probability applications. So in this example, the coin landing on heads will be called a success since this is the event that we are interested in finding the probability of. Step 3. The next step is to identify the variables in the problem. What is the number of trials? The coin is flipped 5 times, so the total number of trials is 5, so we say n equals 5. What is the probability of success? The probability of getting heads is 1/2 or 0.5, so we say that p is equal to 0.5. The number of successes x. The problem asks what the probability is of getting heads exactly 3 times, so x equals 3. Lastly, we need to enter these 3 values, n, p, and x, into StatCrunch to calculate the probability of this event. First, I'm going to list the steps of how to use the binomial calculator in StatCrunch. Then I'm actually going to go to the web browser and walk you through this step by step. First, you go to statcrunch.com in your choice of web browser. Log on to the site and then click on Open StatCrunch. Click on Stat, Calculators, Binomial. When you do, a screen that looks like this should appear. The first thing you need to do is enter appropriate values for n and p based on the values you found in your example. So here's n and here's p. Put your cursor there, delete the values that are there, and put in new values that are appropriate for your problem. Next, you can see that there's an inequality sign here between the x and the 5. If you click on this, it's actually a drop-down menu, and you can choose different inequality and equality symbols. Choose the appropriate symbol. Next, you need to change this value here. Lastly, if you hit compute, the probability will appear in the space here and you can record the answer. Now I'll walk you through the process showing you what my screen looks like. As you can see, I've already navigated to the site statcrunch.com. I've also already logged in. So my next step is to click on this yellow button that says Open StatCrunch. Once you're here, you're going to go up to this menu and you're going to go over to Stat. You don't even have to click anything. Just by hovering your mouse over the word Stat, the drop-down menu appears. The very first choice is Calculators, and again, just by hovering your mouse over the word Calculators, this menu appears as well. The second choice here is Binomial, and I am going to left click on that. At this point, this comes up. So in our last problem, we said that we were conducting 5 trials because we were flipping a coin 5 times. And the probability of getting heads is exactly 1/2 or 0.5. So we don't need to change this probability for this particular example. Then if I click here, again, you can see the drop-down menu. And we want to know what is the probability of getting exactly 3 heads. So I'm going to hit equals and then 3. And then if we hit compute, you can see that the probability of getting exactly 3 heads in 5 trials is 0.3125. It's also important to notice that we have this discrete probability distribution graph as well. Notice that this bar right here that represents exactly 3 heads is colored red, while the other bars are still black. It's important to compare this equality or inequality with the graph to make sure you have captured the correct values of your random variable. Returning to our example, we just calculated the probability of getting heads exactly 3 times. So to summarize, the probability of getting exactly 3 heads in 5 trials is 0.3125 or 31.25%. Let's do another example. Example 2 is rolling a die. A person rolls a die 10 times and records whether or not a 6 was rolled. What is the probability that a 6 was rolled exactly twice? Step 1. The first thing you should do is check that all 4 requirements of the binomial are met. Then, determine which event we're calling a success. In our case, we're calling rolling a 6 a success, since that's the event we are interested in finding the probability for. Next, we need to identify the variables. How many trials are there? Well, we're rolling the die 10 times, so the total number of trials is 10. The probability of success is not explicitly stated here, but we're going to assume a fair die, so the probability of rolling a 6 is 1/6 or 0.1666667. The number of success is x. The problem asks what the probability is of getting heads exactly twice, so x equals 2. So now we have to go over to StatCrunch, the binomial calculator, and find the probability. As you can see, I'm already in StatCrunch, and these are the values from my previous problem. So this time, remember we have 10 trials, so n is 10. This time the probability of success is 1/6, so I'm going to put as many digits after the decimal point as possible, just to give the most precision I can. And then we're interested in the value of exactly 2 dice rolls that result in a 6. So that should be all the information we need to give it. This time I didn't have to change the equality sign because it was already an equal sign from the last problem. So let's hit compute. Okay. Again, if I look at this graph, I can see that the bar for the probability that 2 dice rolls resulted in a 6 is red, while the rest of them are black. So I can be assured that this is giving me the probability that I'm looking for. And as you can see, the answer is about 0.29. So now we can go back and write that answer down. Returning to our problem screen, we say that the probability of rolling exactly 2 6s in 10 die rolls is about 0.29 or 29%. Example 3, pacemakers. A person is tasked with determining whether each of 9 heart pacemakers is acceptable or defective. Suppose the probability of a defective pacemaker is 2%. What is the probability that exactly 1 pacemaker is defective? Remember, the first thing you need to do is to check that all 4 requirements of the binomial are met. Then we need to determine which event we're calling a success. In this case, we're interested in the probability of a defective pacemaker, so that is how we will define success in this problem. Now let's go ahead and define our variables. How many trials are in this problem? There are 9 pacemakers, so n equals 9. What is the probability of success? So remember, we define success as the defective pacemaker, so the probability of that is 2% or 0.02. And then lastly, how many successes are we interested in? So the problem asks, what is the probability that exactly 1 pacemaker is defective? So x equals 1. At this point, we have enough information to go over to StatCrunch and use the binomial calculator to calculate p of x. Let's go ahead and do that. So again, I've already navigated to StatCrunch and logged in. You might already have StatCrunch open if you've been doing these other problems. So now we click on Stat, Calculators, Binomial, and again we have the binomial calculator open. So let's change our values. So remember we said that there are 9 trials, so n equals 9. We said that the probability of success, which we're calling a pacemaker being defective, is 0.02. And then remember we want to know the probability that exactly 1 is defective. We hit compute. Okay, and hopefully you can see here the probability is about 0.15. So returning to our problem screen, we say the probability of exactly 1 pacemaker being defective is about 0.15 or 15%. So the last thing I want to cover in this video is how to create a binomial probability distribution. And this is almost the same as what we've been doing with one important exception. So let's begin. We're going to go back to the first example we did with binomial probabilities, where we said that a person flips a coin 5 times and records the number of heads. This time, instead of just calculating a single probability, so for example, what is the probability of exactly 2 heads or something like that, we're going to create an entire probability distribution. So just as always, we want to always check the 4 requirements of the binomial. Then we want to define success. In this case, we're calling the coin landing on heads, we're calling that success. And then we want to go through and identify our variables. So the number of trials is 5 because we're flipping the coin 5 times. The probability of success is 0.5. We're going to assume that this is a fair coin, so it has a 50-50 chance of landing on heads or tails. And then this is where things get a little bit different from the problems that we've been doing. In all of the other problems that we've done in this video, we've only had a single value for x. But this time, if we want to create a complete probability distribution, we are going to go through and evaluate the probability for all 6 possible values of x. And then, as you might imagine, we want to organize that information, and we're going to organize it into this table, and this table is a binomial probability distribution. Once you see that this is something that you're required to do, hopefully you can see the utility of using technology and a binomial calculator rather than evaluating that formula manually 6 different times for 6 different probabilities. So let's go over to StatCrunch and we're going to enter these values and we're going to calculate 6 different probabilities so that we can complete this binomial probability distribution. So you can see here I already have the binomial calculator open. So we make n 5, we make the probability of success 0.5, and then we're going to start with x equals 0. So if I hit compute, the probability that all 5 coin flips are tails or that none are heads is 0.03125. Now, when you're doing your homework, it might ask you to round to a certain number of decimal places. For this particular problem, I am not going to round. I'm going to copy down all of this information and put it in my table. So let's say that we've copied this down onto our work. So now we're going to move on to 1 and hit compute. So this time the probability is 0.15625. So again, we copy that down and we move on to 2. So the probability that you get exactly 2 heads and 5 coin flips is 0.3125. Copy that down, put in a 3. Again, the probability is 0.3125. Write that down, move on to 4. 0.15625, and then lastly 5. Okay, so again you have 1, 2, 3, 4, 5, 6 different values of x, so you're going to have 6 different values for your probability. So coming back to our problem slide, we have this empty binomial probability distribution, and we just calculated these 6 probabilities, so we just fill in the table and then we're done. Having watched this video, you should now be able to identify n, p, and x in a binomial distribution example. Use StatCrunch to calculate the probability p of x of an event in a binomial distribution, and construct a binomial probability distribution using StatCrunch.